Good day, class. In our discussion last meeting, we have a brief introduction about the nature of biostatistics and the different type of data that we could encounter when processing them using different statistical tools. So for the focus of our discussion today, we will mainly discuss the sampling and data collection. For sampling and data collection, this would include a process flows that has 8 steps. First steps, namely, would be the definition of the target population, wherein we select the population of interest for the study that we will be conducting. Next step would be selection of the sampling frame. We will be now choosing which part of the population fits the best interest of the researchers or those individuals that are collecting the data. Third step would be determination of the sampling method. So namely, we have two methods of sampling. We could either utilize a probability type of sampling or a non-probability type of sampling. So we will discuss that further as we go along with our discussion for today. Step number 4, plan the procedure for selecting samples. This would now include how are you going to select the best samples for the data that you would want to obtain for your study. Next, step number 5, determine the sample size. So how could we determine the sample size from a population or a larger group of individuals? So we could just simply utilize a formula so that we could effectively get the number of those representatives that will be coming from a larger group. Step number 6, selection of the actual sampling units. We now need to determine which part of the sampling frame we are going to utilize for our study. Next, step number 7 is conducting fieldwork. So why do we need to conduct fieldwork? We are now ready to get the samples or the data that we need for our study. And our last step, which is step number 8, is the processing of the data, wherein we just simply summarize the findings from the data that we have collected. So let us discuss now population and sampling frame. In our discussion last meeting, we have already given the definition for both population and the sample. So your population would just be the set of complete collection or the totality of all possible values of a variable. So what I have utilized here in our presentation to represent the population would be a sun. So it has different rays. So the number of rays would depend on the illustration. But if you could notice, I have utilized the capital letter N to represent the population. The sample, on the other hand, is the one that we obtained that will represent the population. The sample is represented by the small letter n, which is just a subset or a sub-collection of the elements drawn from the population. So how do we really determine the sample from our population? Generally speaking, there is no set of rules with regards to the collection or obtaining the sample from a population. However, the higher the percentage of the sample, the higher the validity of the study. So let's just simply say the more individuals that would partake or participate rather in your study, the more valid the results that you could obtain from the manner of collection of the data. So we will also discuss at the latter part of our lecture the different methods of collection of data. Next note that we should take note. The bigger the population, the lesser percentage of the sample is taken. So we'll prove this later on once I will be discussing the actual computation for the sample size. And lastly, For a specific calculation of a sample for the purposes of adequate sampling, so do take note, I will be pointing out the word adequate. What we utilize is a formula known as the Slovin formula. So let us now discuss how do we compute for the sample size. So the formula being shown on your screens right now is actually the simplified formula for proportion, wherein the small letter n represents the sample size, the capital letter N represents the population size, the small letter E represents the margin of error. So how would we identify which margin of error we should utilize for our study? It would depend on the researchers themselves. If you would want a larger margin of error for your study, the most commonly utilized is a 5% margin of error. But if you would want to have a more accurate results, meaning you are only giving a small margin of error for your study, then what you could utilize is a 1% margin of error. So for the actual formula, we have here small letter n, or the sample size, is equals to n, which represents again our population size, divided by 1 plus the product of your population size and the square of your margin of error. So for you to appreciate our Sloven's formula, let's have sample problems here. So let us compute for the sample size for each of the following population sizes given a 5% significance or margin of error. So the first population that we have over here is 10,000. So what we are determining here is again your small letter n, which represents your sample size. So again, it is computed as the capital letter N, or your total population, which is 10,000, divided by 1 plus the product of your population, which is again 10,000 for our first problem here or given, and the margin of error, which is 5% or equivalent to 0.05 squared. So what we could obtain from the computation of a 10,000 population is 384.61. But if you will be using a living thing for your study to be considered as participants for the data collection, we always need to round up. So do take note that you could not take an individual which is only 0.61. So we round it up. So from our value 384.61, approximately the sample size for a 10,000 population would be 385 individuals. Next, we have here 256,000 and 112,675,879. So we will still be utilizing the same formula. Small n is equal to capital N over 1 plus the product of capital N and E squared. But if you could observe, even though that we have here different values, 256,000 and 112,675,879, the computed sample size for both would be 400. So this is already rounded up. So from the actual computation for a 256,000 population, it would be equivalent to 399.37. So we round it up. Then what we could obtain for our sample size is 400. But for our 112,675,879 population, the computed value is 399.99. Rounded up, it would be approximately equivalent also to 400. So what is the specific reason for that? So depending on the population and the margin of error that we will be utilizing, there would be a set of quota, or in layman's term, there would be a limit with the number of participants, which would represent our population. So for this instance, for a 5% margin of error, the limit for the number of our samples would be equivalent to 400. For a 1% margin of error, it would definitely be higher as we will be obtaining a more accurate data from the number of our individuals that will partake with our study. Next thing that we should discuss is the sampling method and the planning sample selection. So we have two methods here, which are probability and non-probability. So before we dive deeper with the actual techniques of obtaining our samples, let us differentiate first probability from a non-probability sampling. So for probability sampling, we acquire a representative of the sample of our population. But for non-probability, if we will be contrasting it with the probability type of sampling, it is not necessary that we obtain a representative sample from our population. Another thing, with regards to generalizations, we utilize probability if generalization is being sought to be made with the conclusions. But for non-probability sampling, generalizations cannot be made. Another difference between the two. For probability sampling, this refers to the sample as part of the population, but for non-probability, the population is actually not being considered. And for the last difference between the two types of sampling selection, for probability, every individual of the population has the same probability, or in layman's term, they have equal chances of being selected as a sample or representative of the population. But for our non-probability sampling, probability is non-existent. So let us now identify the different techniques under probability and non-probability sampling. So we have here our sampling techniques under probability. We have simple random sampling. We have systematic sampling. We also have cluster sampling. And the last type is the stratified sampling. For our non-probability sampling, we have our purposive sampling, the quota sampling, convenience sampling, and lastly, we have the snowballing sampling. So let us discuss each type of sampling techniques for each sampling method. So let us discuss first those that are classified as probability type of sampling. So the first example that we have here is the simple random sampling, which is also known as the fishbowl method. So in this technique, the elements of the samples are being selected through lottery, or what we commonly know as the draw lots. So you could just obtain a container, write the names of your individuals or the whole population in a piece of paper, let them drop their name on the container or a fishbowl. Then all of these individuals have the same chance of being selected to be part of the study, or if you are using it for drawing individuals who will win the lottery, this, as the name implies, then all of them will have the same chances of winning. So we will be randomly selecting the individuals that will be selected from the population that we have. Even though that this is a good type of sampling technique, this is actually not ideal for a population that is too big. So let's say that you have 100,000 participants. So for your side, as a researcher, you need to write down the names of those individuals, cut out the papers. Then for a 100,000 sample, how many individuals will be needed for your sample size? So you need to draw multiple times from the fishbowl or container that you have. But for modern practices right now, we have already eliminated that difficulty of writing and cutting papers. just for draw lots, we already have some applications that we could just simply type in the names of the individuals that could partake with our study, or if you are having draw lots for a certain price that you would want to give to the winners, then the program will be the one that will select the individuals that would win or will be selected to partake or participate in our study. Next type of probability sampling here is the systematic sampling. So this technique of sampling is done by taking every element of the population assignment of the number as the part of the sample. So from the illustration that you are seeing right now on your screens, we have here 12 individuals. And what we have selected from the 12 individuals would be the person that would be the third for every counting from our population. But, ma'am, why is it that the individual number 2, 5, 8, and 11 are being selected from the study? So for this one, it would still be a random. You could select a starting point from the number of individuals that you have. So let's say, again, from our example here being shown, we have 12 individuals. Instead of starting the counting of every third individual from number 1, we have started from number 2. So number 2 will be selected, then count 3 individuals, 1, 2, 3. Then you have your fifth individual. From number 5, count again 3, 1, 2, 3. We have selected participant number 8. And lastly, from number 8, count again 3. And it would be your individual number 11. So it would be represented as your letter K, which is simply the individual that would be for every count. Will it be the individual for every 12 second count? 12 count? Or depending on the sample that you have. So let's have another example for systematic type of sampling. So again, for our systematic sampling, to select the number or the sample size from our population, we just simply divide the population with the sample size, and that would serve as your K. So for this one, we have the third individual. So let's apply this formula. So we have here a total of 100 individuals. So your N or your population is equivalent to 100. And the sample size computed from 100, let's say, is equivalent to 20. So to identify what is the number of individuals that will be selected from the population that you have, we simply divide the population with the sample size. So capital N divided by N will now be equivalent to 5. So you will be choosing the individual for every 5 counts. So for this example, the researcher decided to start the counting from number 4. So automatically, your individual number 4 will be included in your study. Then count 5 from number 4. 1, 2, 3, 4, 5. Then that will be your individual number 9. So from the example that I have shown on your screens right now, all the individuals colored blue are the ones that will be selected to participate in our study. And that would still be equivalent to the sample size of 20 from your total number of population, which is 100. Next type of probability sampling that we have here is the stratified sampling. So in the stratified sampling, you still have your population, but your population will now be divided into 2 subpopulations, or what we consider as the strata. So this will be your subpopulation. So how will we identify what will be the groupings for our subpopulation or strata? They will be divided based on the same characteristics that they will be sharing. So let's say the red individuals will be the female patients that we have, and the blue individuals here would be your male individuals. Then from each strata that you have or subpopulation from the red and the blue ones, you will conduct a random selection. So from the red individuals, the sample that we have obtained would be 4. And for the blue individuals, which represents our male patients, would be 3. Now, you may be confused why the number of individuals from our female and male patients differs. It actually is based on the pattern that would still be relying on the number of your population and subpopulation. Since the female patients are more numerous compared to the male patients, then definitely the sample size that we could obtain from the female patients would be bigger or more compared to the male patients that we have. The last type of our probability sampling is a cluster sampling. So from your population, you will be dividing the individuals into what we consider as sections, or we could also call them as clusters. Then, once you have divided them into sections or clusters, you could randomly select. So let's say for a total of 140 individuals, which would be your population, you will be obtaining a sample size of 70. So with that, you need to obtain at least 5 clusters. So that would be our example. So from our illustration being shown rather on your screens, those individuals colored red will be the ones that will be included in our study. So for our stratified sampling as well as cluster sampling, we actually utilize a formula for a more accurate method of identifying which would still be included in your study. So the formula that we utilize for the determination of the sample size per strata or subpopulation, which would depend on the proportional allocation, would be as follows. We have n, small letter n, sub 1. So this number that is subscript would depend on the number of strata or subpopulation that you have. So let's say that you have 3 subpopulations, then you have n sub 2 and n sub 3. This is equivalent to the total sample size. So this is for the totality. Usually, this is given divided by your total population multiplied by the population of your first stratum. So let's have an example. So you have here a sample of 50 students, which will be drawn from population consisting of 500 students belonging to 2 institutions. Your institution A has a population of 200 and your institution B has a population of 300. So how will you draw the sample using proportional allocation? So from this given, we have two strata or 2 subpopulation. So based on our given, it will be represented as small letter n sub 1 and small letter n sub 2. So the total sample size that is being given here would be 50. So it would be equivalent to 50 here, divided by the total population of the students coming from the 2 institutions, which is 500. So since you are computing first for the sample size for your stratum 1 or subpopulation 1, which has a total population of 200, you multiply it by 200. And what you could obtain here is 20. Next, for your stratum number 2, or those individuals that will be drawn from your institution B. So our total population, or total sample size rather, would be 50 students again, divided by the total population of 500 multiplied by the total population of your stratum 2 coming from your institution B, which is 300, and that would be equivalent to 30. So the sample size that will be obtained from institution A would be 20 students, and from stratum B, it would be 30 students. So from this number of students that we have obtained from the computation, you could do simple random sampling or random sampling. You select 20 students out of the 200 students from your institution A and randomly select 30 students from the 300 total students from your institution B. Let's have another problem. So please do take note that not all of the time we could accurately compute for the given total sample size. So from this given, the total sample size is 50. So let's have an example with regards to that. The total population that we have here is 322. And the margin of error is set at 5%. And the total sample size is equivalent to 179. So unlike the first given that we had on the previous slide, wherein we only have two strata or two groups, for this one, we have 7 units or clusters. So for this one, let's have a sample computation. Your unit 1 is N1 is equivalent to N, small n, divided by capital N, multiplied by the population of your cluster 1. So that would be 179, which is our total sample size, divided by the sample population of 322 times 5. So for this computation, the value that we could obtain would be equivalent to 179 divided by 322 divided by, 179 divided by 322 times 5, and that would be equivalent to 2.779. So if we are referring to living organisms, so let's say you would want rats as your participants for the study that you are conducting, then you will not be able to obtain 0.779 proportion of that rat or mice. So you round it up. So that would be equivalent to 3. So you just utilize the formula for the succeeding units that we have. Again, each unit would represent their own numbers. So what would be different with the computation would be the total population for each stratum, subcluster, or subpopulation that you have. So even though that based on our given, the total number of the sample size is 179, since for most of our computation, we will be obtaining values that have decimal numbers or they are not in whole numbers, we need to round them up. So if we add all of the values from the result of our computation, the number that we could obtain would be equivalent to 182 individuals, which would be 3 individuals higher compared to the given sample size. So there wouldn't be any issues with that, since based on the explanation that we have earlier, the more individuals that would participate in your study, the more accurate the result that you could obtain. So those are the different probability sampling techniques. So let's proceed with the non-probability type of sampling. The first one that we have here is the purposive sampling, which is also known as the judgmental or authoritative type of sampling. So with this type of technique, the elements of the samples are being selected according to criteria or a set of roots. So let's say from this individuals that you have for your population, you will be selecting those that are hypertensive. So let's say that those individuals that are fully shaded or are black in color would represent the individuals that are hypertensive or have high blood pressure. Then we select them from those set of population that you have, and that is what we call as a purposive sampling. Again, we are setting here rules or criteria for the selection of our participants. Next type of non-purposive sampling is the quota sampling. So in this technique, the sample size is limited. This would be limited based on the required number or subject in the study. So let's say that you have only set from a total of 12 individuals, you would only obtain 4 individuals that are, from our representation being shown on your screen, male patients, which would be ages 40 and above. So we have here, just like with our purposive sampling, we set criteria, but we only limit the number of individuals that will participate in our study. So since we have set, we will be selecting 4 individuals, then you select only 4 persons that are considered male and are above 40 with regards to their age. Next type of non-probability sampling is the convenience sampling, also known as the haphazard or opportunity sampling. So in this technique, the sample are being selected from a particular place at a specified time. So let's say that you will be conducting your research and you need to obtain data from individuals that are male, which would be ages 18 to 25 years old. So how would this type of sampling differ from the other types of non-probability sampling that we have already discussed? For convenience sampling, you will be doing this at your own convenience. So let's say you will be selecting your participants from your classmates or those medical laboratory students that are having their class right now. So it would be easier for you to approach them since you do not need to go to other places on a given time. You will just simply select the individuals that will fit the criteria that you have set on a particular place at a specified time. And the last type of non-probability sampling that we have is the snowballing sampling. So in this technique, the researcher will ask respondents to give referrals to other possible respondents. So if this type of sampling is familiar with you, it is actually being utilized in some of the marketing techniques. So yun yung tinatawag natin na sorry for the interruption, what we call as the networking procedure. So for this snowballing sampling, we actually have 3 types for snowball sampling. One is the linear snowball sampling. So it doesn't branch out. So one individual needs to look for another individual that would partake or participate in the study. Then that next person would find another one to participate in the study. So it would just be a 1:1 ratio. One person needs to find another one that will participate in the study. Next one is the exponential non-discriminative snowballing sampling. So this actually branches out. So from one individual, they will find another two individuals, or they would refer another two persons to participate in the study. And those two persons, again, will find another two individuals that will participate in the study. So the number just increases based on its name. We have exponential, but it is non-discriminative snowball sampling. We also have exponential type of snowball sampling, but it is discriminative. So let's say we have left and right hand. So an individual will select two individuals, and those that would represent their left hand will now be excluded from the study. So hence the name discriminative. So with this type, it is almost a linear type of sampling, since there would only be a 1:1 ratio for those individuals that will be included in the testing. So those are the different sampling techniques that we could employ when we conduct collection of our data. So having said the term collection of data, we have different data collection techniques. So we will just have an overview of the basic data collection techniques that we could employ for your research. So we have the following. We have survey, we have interviews, observation, and experimentation. So for surveys, we simply give questionnaires to the given or the chosen respondents that will participate in your study. So the questions, of course, would definitely be based on the study or the objective of your study. Next, interview. You are directly asking questions from the respondent. Next, we have here observation. So we just observe behavior without intervention. So we record what we could observe from what is being done by the participants of our study. And lastly, experimentation. This is observation of behavior or effect with the identification if there would be changes of the results before a certain treatment or after a certain treatment, or what we consider as the intervention in our study. So this would be the last part of our discussion for today, which is the summary of the different data collection techniques or methods that we could employ. For survey, we have lots of respondents. It would require less effort, less manpower, but there is errant respondents. So what would this mean? We do all know that there are some respondents who will not truthfully answer our questions. So pwedeng tinatamad silang sagutan or hindi nila naiintindihan kung ano yung tanong na nakalagay doon. So what they will do is a shotgun technique. So let's say that your questionnaire includes a grading. So they would rate from 1 to 5 depending on the prevalence or gaano kadalas nila ginagawa ang isang bagay. Halimbawa, meron nakalista doon sa questionnaire natin. Dahil tinatamad silang basahin kung ano yung nakasulat sa questionnaire, randomly, maglalagay lang sila ng answer. And with that, even though that you have lots of respondents, the data that you could obtain after summarization will be affected since there would be varying answers from one individual to other. Next, for interviews, it would be ideal for small number of respondents. Then it would be a type of primary source of data, just like what we have discussed last meeting. So you as a researcher would obtain the data from your respondents face-to-face. But with this type, even though that you would require a smaller number of respondents, it would require a lot of manpower. So to increase the speed of obtaining data, you may require more researchers that will obtain your data from the respondents. Next, observation. This is observing respondents or samples without intervention. This is ideal for characterizing behavior. And lastly, experimentation. Again, this is an observation with intervention. So usually, we will be comparing the results before and after a treatment or intervention. And that ends our discussion for today.